All right, we are going to talk about measuring angles and arcs. So the first thing we are going to define is a central angle. A central angle is an angle formed by two radii with a common endpoint. The vertex of the angle is the center of the circle. So a central angle would be something like this. I'm going to call this point P. I'm going to call the vertex Q. And I'm going to call this point R. So angle P, Q, R. A minor arc is an arc on a circle that is less than 180 degrees. So less than half a circle. So for example, if I have central angle PQR, then this right here would be my minor arc. We write the two endpoints of the arc. We do not write the vertex, and we put a curve over the top of it. If the measurement of angle PQR is equal to 80 degrees, then the measurement of arc PR is also equal to 80 degrees. Good morning. Thank you, Alexis. A major arc is an arc on a circle that is greater than 180 degrees. So more than half a circle. So if this is my circle, and I have points A, B, and C on the circle, this arc right here would be a major arc because it is more than half a circle. When we name a major arc, we need 3 letters. And then it still gets the curve over the top. So a minor arc is 2. The 2 points that are closest together for my minor arc. For my major arc, the way I know I'm going the long way around between points A and C is because of that point B. If I just had AC, it would be this right here. But because it's ABC, I know I have to go the long way around like this. If the measurement of angle ADC, not ABC, ADC, is 80 degrees. Then the measurement of arc ABC is equal to 360 minus 80. Remember, all the way around the circle is 360 degrees. So the measurement of this arc right here would be all the way around a circle, 360, minus this little bit over here. Then we have a semicircle. A semicircle is exactly 180 degrees, exactly half a circle. So this right here would be a semicircle. I'm going to go ahead and name this F. I'm going to call this G. We're going to call this H. So this is a semicircle, arc FGH. Because it is more than a minor arc, it is not less than 180, we name it with 3 letters, just like we do with a major arc. So FGH is a semicircle. It's equal to 180 degrees. Segment FH is a diameter. Every now and then you will see a semicircle written with only 2 letters, but that's very uncommon. Semicircles, you need to name them with 3 points. All right. Let's see if we can do some practice problems with these ideas in mind, talking about angles and arcs. You're welcome. Remember, 1 full revolution around a circle measures 360 degrees. Number 2, part A says find x. X is right here. And because 1 full revolution around the circle is 360 degrees, this is the sum of the central angles. So number 2, part A, I'm going to add those central angles together. How big is this angle right here? 90. So we're going to do 90 plus 40 plus 85 plus x equals 360. So now we need to combine our like terms together. What do we get when we combine 90, 40, and 85 together? 215. So 215 degrees plus x degrees equals 360 degrees. Then I'm going to subtract 215 from both sides. And that means x is how big? 145. All right. Let's try that with part B now. X is right here. So we're going to add those three central angles together. We have 165 plus 145 plus X, and we set that equal to 360. So now we combine our like terms, 165 and 145, 310 plus X degrees equals 360 degrees. So how big is X? 50 degrees. Nicely done. So far, so good? So the sum of the measure of the central angles is 360 degrees. The sum of all the arcs on a circle would also be 360 degrees. All right, let's scoot down the page and go look at number 3. It says PM is a diameter of circle R. Identify each arc as a major arc, minor arc, or semicircle. Then find its measure. So the first one that they ask us for is MQ, right here. MQ. Is that a minor arc or a major arc or a semicircle? That is a minor arc. All right. And now we want to know how big it is. It said that PM was a diameter. This is a diameter, which means this would be what? It'd be a semicircle. How much does a semicircle measure? 180 degrees. So I have 180 degrees is equal to, I'm looking over here, these two arcs together make that 180 degrees. So 115 plus the measurement of arc MQ. So to find the measurement of arc MQ, I'm going to subtract 115 from both sides. What is 180 minus 115? 65. So 65 degrees for arc MQ. All right. Let's look at part B now. Arc MNP. MNP. Minor arc, major arc, or semicircle? Semicircle. What did it say at the very beginning of the directions? What did the very beginning of the directions say? PM is a diameter. What does a diameter do to a circle? Cuts it in half. Here's PM, and here's our arc. When the arc touches the two ends of the diameter, when that's where the arc stops, then you have a semicircle. You will always have a diameter, or you will always be able to identify a diameter when you have a semicircle. What is, you're welcome, the measurement of arc MNP? 180. Because it is a semicircle. All right, so that leaves MNQ, MNQ, all the way over to here. Minor arc, major arc, or semicircle? Major arc. Now we want to know how big that major arc is. The measurement of arc MNQ is equal to a whole circle, 360 degrees, minus that little bit that we left out in between M and Q. Didn't we figure out a couple minutes ago how big that was? How big is that? 65 degrees, yes. This is 65, so this is 65. So we're going to subtract 65. What is 360 minus 65? 295. So the measurement of arc MNQ is 295 degrees. All right. Let's try the same type of thing down here on number 4. This time, what do we know from the very beginning? GJ is a diameter of circle K. So what is GJ doing to the circle? It's cutting it in half. So arc GH, which would be this arc right here, would be a minor arc, a major arc, or a semicircle? Minor arc. How much would that minor arc measure? 122 is correct. 122 degrees. Measurement of arc GH is 122 degrees. What about arc GLH? GLH. Minor arc, major arc, or semicircle? Major arc. And how would I find the measurement of arc GLH? Yep, 360 minus 122 degrees is absolutely correct. What is 360 minus 122? 360 minus 122? 238. All right, and then we have our very last one that we're doing on this side of the page, arc GLJ right here. Minor arc, major arc, or semicircle? Semicircle. Which means it measures how big? 180. Beautiful. All right. Let's flip the page over. It says find the measure of the indicated arc on each circle. The measure of arc WY in circle V. So let's go find arc WY. Here's arc WY. How big is this angle? 90 degrees. So this arc right here would also be 90 degrees. How big is this angle? 62 degrees. So this piece of the arc from X to Y would be 62 degrees. So what do you think I need to do to find the measurement of arc WY? Yep. Measurement of WY is equal to 62 degrees plus 90 degrees. What is 62 plus 90? 152, and I wrote segment instead of arc. Measurement of arc WY is 152 degrees. All right, over here on part B, we want arc AD. The measurement of arc AD would be made up of what two smaller arcs put together? 90 and 63. So we have this right here, which means this arc is 90. We have 63 right here, which means this arc is 63. So to get the full arc, we add the 90 and 63 together, and we get what for arc AD? 153. All right. We are going to use Circle A to answer the following sets of questions. I want to know which word best describes the following parts of Circle A for part A here. So first thing we're looking at is segment DA. This right here. What do we call that? It's going from where to where? This is a radius. Yes, it goes from the center to the edge of the circle. So this is a radius. Let's look at BE next. From B over to E, what do we call that? That's a diameter, yes. And then we have BC right here. That's a chord, absolutely. All right. For part B, we're still going to be identifying what these are called, but then we are also going to be finding the measurements of those parts. So the first one that we have down in part B is arc BE. This right here, minor arc, major arc, or semicircle? Semicircle. So this would be one of those circumstances where they wrote it with only 2 letters, but we should name semicircles with how many letters? We should use 3. So we could call this arc BCE. Or BDE. How much does it measure? 180. All right. Let's look at the next one. Arc CBF. CBF. Minor arc, major arc, or semicircle? It's a major arc. A semicircle has to measure how much? Has to measure 180. How much does this arc measure? 190. So we have 90 and 100 right here. So this measures 190 degrees. All right. Now we have arc DC, this arc right here. Minor arc, major arc, or semicircle? Minor arc. Now we need to figure out how much it measures. What did we call BE again? That's a diameter. And what do diameters do? Cut circles in half. So we know from E measured around this way, this is how many degrees? 180. How big is this much of the arc? 90. How about this much of the arc over here? 50. So how do I find the measurement of DC? Yep. We're going to do 180 minus, and then I need to put that 50 and 90 together. You said that's 140? So that'd be 180 minus 140, which would be how much? 40 degrees. All right. One more part to this question. I want to know what angle EAF would be called. What do we call an angle that has its vertex in the middle like that? Central angle. And now we want to find the measurement of this central angle. What would we call this arc, BFE? That'd be a semicircle. And do we know how big part of that semicircle is? Yes, BF is 100 degrees, so that means EF would have to be how big? Has to be 80. We have 180 minus 100 to get that 80-degree arc. So this is 80. This is 80. This is 40. This is 40. This arc is 50. And we have this angle is 100 here. And then we have our other 90-degree angle right here. All right. We have one more problem that we're going to do for today. We're going to look at number 7. In the circle, QT and UR are diameters of the circle. If the measurement of angle QPU is 4x plus 11, find the values of x and the indicated arcs and angles. So let's go find angle QPU first. QPU. This angle right here is 4x plus 11 degrees. All right. What did it say the diameters were? QT and UR. So this is a diameter. And what do diameters do to circles? Cuts them in half. So how big is this arc right here? 180. So I can use that because I know that this little piece over here is 45. So I can say 4x plus 11 plus 45 equals 180. Now I can combine these two like terms, the 11 and 45 together. What would that give me if I combine those? 56. So 4x plus 56 equals 180. I'm going to subtract 56 from both sides. What is 180 minus 56? 124. So 4x equals 124. Then we divide both sides by 4. What do we get for x? 31. Not degrees, because we didn't find an angle. We didn't find an arc. We found something that makes up part of an angle, part of an arc. So we don't put degrees on that. All right. Let's see if we can find these other measurements now. We want arc UT, 45. We know that QR is 45 degrees, that arc. So this angle here would be 45 because of vertical angles. That means this angle would be 45. So arc UT would also be 45 degrees. QRU. Let's look at the picture. QRU. What did we say RU was? It's the diameter. So arc RSU would be 180, and onto that we need to add an additional what? 45. So 180 plus 45 would give us what? 225 degrees. Two more. USR. How big would that be? 180. Arc USR is a semicircle, so that would be 180 degrees. And now we just have one piece left here, the measurement of angle SPR. SPR. We're looking for this right here. We said from here around to here was how big? 180. And I know this much is 45. This much is 71, so I have to do 180 minus 45 plus 71. That would be 180 minus what? What is 45 plus 71? 116. And what is 180 minus 116? 64. Very nicely done. Tomorrow during the teams meeting, we will do the two problems down at the bottom, numbers 8 and 9. And the homework that you guys picked up on your way in the door is due on Wednesday. Homework is due on Wednesday. We will begin our live instruction at 8 a.m. tomorrow. Your first teams meeting for this class will be at 8 a.m. tomorrow.